So equilibrium of particles. As per this principle, we have to say that if a particle is in equilibrium, static equilibrium, if a particle is in static equilibrium, then all the forces acting on it, sigma f x equals to 0, and all the forces acting on it on y direction equals to 0. So here is, suppose a particle is, or you can say in Cartesian coordinate system at point A, if I am having number of forces acting in this directions, and suppose the resultant is in this direction, the resultant is represented by r, then you can say if if A is in static equilibrium, then there has to be some force that should be, then there has to be some resultant force that is actually opposite and equal in magnitude to the resultant of these four forces. So because of that, the net force on A is resultant R plus resultant, or you can say the another force R dash. Since R dash is having same magnitude as R, and also the directions of the two are opposite, therefore R plus R dash is equals to R minus R, that is 0. Total force on A is 0 if A is in static equilibrium. So you can, for only two forces, you can also say that if force A is acting on point A, that magnitude of force F is, it is modulus of F, and it is acting along positive x direction. And if you are saying that point A is, at point A there is static equilibrium maintained, then there has to be some another force acting in opposite direction having same magnitude as the given force F. For system of three forces, suppose if we are having at point A, if we are having three forces acting F1, F2 and F3, and suppose the resultant is somewhat inclined to y-axis in this way at angle theta, this is the resultant R of F1, F2 and F3, then there has to be some another force R dash that is equal in magnitude to the R and opposite in direction to R, so that total force acting at point A are 0, that is A is in static equilibrium. Now as far as dynamic equilibrium is concerned, dynamic equilibrium, for this, suppose a body is there, suppose a car is there and it is moving on a road, and with an acceleration of A is equals to 2 meter per second square, then you can say that because of this force 5 kilonewton and the mass of body M is 2500 kg, so your external force F will cause an acceleration of 2 meter per second, that is F equals to ma. That simply the value satisfies the equation over here. So in this case, and if there is friction force acting in this direction, so you can say that total force acting on body is ma, or since the body is moving with an acceleration A is equals to 2 meter per second square, so you can say your frictional force Fr is equals to ma. But now if you want to write it in dynamic equilibrium condition, we need to write it as Fr minus ma equals to 0. This is actually D'Alembert's principle, which explains that when a body is moving with constant acceleration A towards a particular direction, body experiences some inertial force opposite to its direction, and the magnitude of force is same as ma. That is, the acceleration that is the magnitude of force is same, and its sense is opposite to the motion of the body. And this physical phenomenon can also be explained when we are standing in a bus, and suppose bus suddenly starts, our legs tend to go along with the bus, whereas our body tends to move as where it was earlier. So body experiences an inertial force because of which we move backward. So simply when we write the equation in this form, Fr minus Ma equals to 0, the RHS represent total external force on body. Total external force on body, that is equals to 0. So although the body is actually moving, but if we consider it from reference of body, then the total force on body is 0. So it is simply known as dynamic equilibrium. So let us now understand the difference between static and dynamic equilibrium. Suppose here is a valley and I am having a ball over here. If I displace it towards this position or this position, it will again come back to its original position. This can be said as static equilibrium. Whereas if I am having a body or if I am having a ball over a mountain, suppose I will displace it slightly from its position, it will go on moving downwards. So in this case the ball is in dynamic equilibrium.